Okay, so for our first unit, we're going to go over the scientific method, as you know, or the method of science. So that will be the title of this unit. First and foremost, you need to know that science is the process that uses observation, so things that we see around us, and investigation, questions that we may ask ourselves to gain knowledge or understanding about events in nature. So ultimately, in order to use observations, investigate something, we have to know what we're doing. And therefore, we need a method, a set of rules or procedures that we use in order to answer a particular question that we may have. So, for instance, Newton noticed that things fall, and we came up with the law of gravity. So, there is a method that we use in order to test this gravity. And we start with our hypothesis, which is an educated guess or a testable prediction. So we have gravity, and we want to know why are these objects falling, and that's how we get our theories, the why, the how. And then in order to describe what happens, we have to experiment and come up with these laws. So our experiment is the organized procedure for testing hypothesis. And we can't just go and drop some pennies off the top of a roof and then say, oh, we've got all of our information. We have to have a control. So it's a standard for comparison. We have to know that all of the events that take place each time that we produce our experiment are controlled in an environment that we know is steady, and exact measurement can be produced from that environment. Constant factors that don't vary in the experiment are super important as well. You cannot do an experiment on a windy day and gather data, and then on a non-windy day and gather data, and expect that the data can be aligned in the same way. You also have variables. These are things that change. So the independent variable is the factor that is adjusted by the experimenter. The person doing the experiment can adjust those. And the dependent variable are the factors whose values depend on the things that we are doing. So we'll go over those things in a little more detail and get a chance to put our hands on these things when we do our methods in class. The last bit of information that you'll need to know and identify with is the scientific law and the difference between law and theory. So scientific law is the rule of nature that sums up all the related observations to describe a pattern in nature. So your laws are your what happens. We know we have a law of gravity because every time we drop something here on Earth, it goes to the ground. We know that no matter what is dropped, it will always come to the ground. So up must come down. This is our law of gravity. There is a what that happens. We absolutely know. And then there's a scientific theory. Now this is an explanation based on experiments, most logically that can be derived. So it's an answer to a question that we may have, just like a law is. Why does the penny drop? But it gives us a more we have to sort of deduce. We have to figure this out in order to get there. So, for example, we have the black hole theory. So, a black hole, we know what it is, we know what happens, but we are still figuring out the how and the why. That's why it's a theory. It deals more with the how and the why rather than the actual what happens. So, both theories and laws are tested. They have experiments, they have educated guesses, and not all theories are made into laws or vice versa, but they work together. So there was a great analogy that I heard once, and it states that theories and laws are like fingers and thumbs. So you have them, and when they work together, you can produce some great information. However, a finger will never become a thumb, and a thumb will never become a finger. So they work together in conjunction, but they are two separate things. They have two separate purposes. So that is really important for you to know that there's a difference between a law and a theory.